Okay, so you're building a rack app and you hit this fork in the road. Do I use NumPy, FAISS, Chroma, or something else completely? And if you go looking for an answer on the internet, almost everything out there is written for a hackathon to build it fast, ship it, and throw it away. But here's the thing to understand first. The right vector store completely depends on what you are optimizing for. In Hackathon, you're optimizing to match the rubric and build fast, and then you're deleting the repo on Monday. That's why everyone says just use files. It checks the box with almost no extra work. But in production, you care about totally different stuff. Does the data survive a restart? Can you filter it, update it? Are you still going to understand the system in 6 months? So the moment you drop the hackathon pressure, finds is the safe bet kind of falls apart. The rule for this whole video is to start from your requirements, not from a library name someone told you to use. Why? Honestly, once you see this, everything gets easier. Every single one of these tools does the same core job. Documents go in, you turn them into vectors, a query comes in, you grab the closest matches, you return the top few. That's it. They're not different ideas. What's actually different between them is four things. Do they persist your data? Can they filter it? How big can they scale? And how much of the machine do you have to babysit? Keep those four in your head. So instead of which library is based, that's a wrong question. Ask yourself five things. What's already in your stack? And specifically, are you running Postgres? Remember that one. And next, how many vectors do you have and how fast is that growing? Also, do you need metadata filtering or hybrid search? Do you want to run infrastructure or would you rather someone else did? And how often does your data change? Answer those and honestly, the tool kind of picks itself. Let me show you. First, let's start with plain NumPy. In a hackathon, this is the hero, like 5 lines of code. But in production, it mostly drops out because just NumPy stops being simple the second you need it to last. Now you're writing the persistence, you're writing the filtering, you're maintaining the update logic. You're basically building a database by hand. So keep it for one of the two things. Whether it be a tiny data set that never changes or like a quick prototype. Next is Chromas. It's interesting because it kind of flips. In a demo, its persistence and filtering feel like overkill, but in a real app, that's exactly the stuff you need. Data that sticks around, filtering by user or source or date. Yes, you must use this one. So Chroma turns into a really solid default for small to medium rack, I would say, when you want something local first without a lot of operations overhead. But is it built for a massive scale? No. But there's the good part. If you outgrow it, you can outgrow it cleanly. Okay, so FAISS. The one thing I want you to remember, FAISS is an engine, not a product. It's a library and an index. It is not a database. No built-in persistence, no metadata, no easy deletes. So when does it actually earn its spot? When you have got a genuinely huge pile of vectors, you need serious speed or fancy index types. And you're already ready to build all the plumbing around it yourself. And that plumbing, that's the exact stuff a hackathon lets you skip. Which is why it looked so easy there and looks like real work here. But this is actually the one nobody actually tells you about if you start your AI engineering with hackathon projects and stuff. It's pgvector. If you are already running Postgres, you have to start here. Your vectors just live right next to the rest of your data. One system to run, one thing to back up, filtering basically for free. And the search itself is pretty much one line of SQL. Order by distance, limit k, done. For a ton of raw apps, this is like the pragmatic answer. And the only reason it never comes up in those FAISS versus Chroma videos is that they were written for a rubric, not for something you actually have to keep alive. In the next video, we will also learn how to use pgvector for the production. And look, the field is actually bigger, more than three libraries, roughly four buckets. First of all, if you want to embed the stuff that runs in process, we have Chroma and LensDB. If it lives inside your database, that's pgvector. Or if you are looking for dedicated vector databases you host yourself, we have Qdren, Weaviate, Milvus, and fully managed where you just hit an API. We have PyCon, so you can just pick the bucket your answers point you to. So let me just boil the whole thing down. If you're already on Postgres, you have to use PT vector, tiny and static. Then go for NumPys. It's genuinely fine. So if you have small or medium and want it local, the answer is Chroma DB. But if you have big and you need real speed, now we are talking files or a dedicated database. Don't want to touch infrastructure at all? You can go managed or Python. And notice files is not the default anymore. It's like a specific answer to a specific problem, which is exactly what it should have been the whole time. So, quick warning because you can mess this up in both directions. If you are under building, it means that hand rolling NumPy for data that has to persist and update, you just rebuild a database badly, but overbuilding is just as real as well. So if you stand up for Milvus for like 5,000 chunks and barely any traffic, that's a bunch of scale you're never going to use. So you need to build for the load you actually have, not the one you're already daydreaming about.